Okay, for this video, I'm going to specifically go over the octet rule and the duet rule, I guess is what they would be called. This is just a, for simplicity's sake, a guiding rule that elements want to have a complete outside electron energy level. They do this through these three ways, either by taking electrons to give them a full set of 8 or a full set of 2, giving electrons so that they have their completed energy level underneath that valence shell revealed, and only that, or by sharing electrons, which they would do through covalent bonding. Let's go ahead and take a look at a couple examples really quick to kind of demonstrate that. Okay, to show how elements meet the octet and duet rule, or kind of follow that rule as a guide here to help us understand how these elements bond with each other, we'll take a look first at how ionic bonding works. And how ionic bonding works is kind of a give and a take, in that a metal, typically a metal, will give its electrons in order to reveal a stable shell. Lithium has this one valence electron that can fit up to 8 in that valence shell there. It's not going to get 7 because it's just not strong enough, so it's going to give this one away to reveal this completed inner shell of electrons, meeting this kind of duet rule since it's further up on the periodic table. Fluorine, however, is only one away from having a full octet. It's going to want to take electrons, and fluorine is actually one of the best elements on the periodic table at taking electrons. It's very good at getting that last one there so that it can look kind of like, well, what a noble gas would look like, which is that full octet. So when they form a bond with each other through either a chemical reaction or some other means, lithium will give up that electron, revealing that full duet in its valence shell afterwards, and fluorine will take that electron, meeting its full octet. Covalent bonding is just a little bit different in that no one element takes one electron from the other, but instead that they share the electrons. This is typically between nonmetals such as hydrogen, oxygen, carbon, fluorine, chlorine, when they bond with each other or other nonmetals. So to look at the simplest example would be just take a look at hydrogen. It has only one electron in that valence shell of it that it has. It's in that first row of the periodic table, which only has 2 elements, which means that this shell here can only hold 2 electrons. So each individual hydrogen only needs 1 more electron. So when they form a bond with each other, this electron and this electron count for this one, and these two also count for this one. So they both have 2 electrons in that they are sharing it, and that makes them feel whole. Okay, to look at just some slightly more complex examples, say that we have an element such as beryllium that has 2 electrons that it would want to give away, and you have fluorine that can only accept 1 electron. But how would that look? Well, you would just add more fluorine. Not you would just add more fluorine would be needed to bond with that beryllium and take the rest of these 2 electrons. This has 2 electrons. This can only take 1. So beryllium's going to give 1 electron to fluorine. Fluorine's going to take that. And then another fluorine or a chlorine or whatever else is nearby that can also only accept 1 electron will come by and bond with that beryllium as well. Same thing in covalent bonding, only the elements share the electrons. So say we have hydrogen and oxygen combining to make water. You would have that 1 hydrogen there that can only accept 1 electron, and that oxygen with 6 electrons. Scrap that. Same thing can be said in covalent bonding. Hydrogen only has that 1 electron, and it really wants to have that 1 more to meet its duet rule. Oxygen has 6, and it really wants 2 more to make that octet rule. Another hydrogen would be necessary to bond with oxygen in order to get that full octet. So oxygen would have 1, 2, 3, 4, 5, 6, 7, 8 now, including the 2 that are being shared from the hydrogens, and hydrogen has its 1, 2, 1, 2, meeting its duet rule there. That's all for the octet duet rule. I hope this was helpful in helping understand how elements bond with each other in these simple ways. If this video was helpful, like and subscribe, and I'll see you all in the next one. Take care.